So these are some logos of some companies that I have worked for. You can see there's a lot of Dow associated things there, but I've also worked for a few other companies. I've also worked in IT director for a hospital, IT director for a university. So my experience that I bring is hopefully not just a Dow perspective, but a perspective of a lot of other different companies I work for. Primary chemical and primary and batch automation process. Interesting story, as we were walking in here, I was kind of talking to my wife, and she said, we got off the airplane, and she said, we saw a big sign that said, "Welcome to the land of make-believe." And she said, "Oh, that's going to be your opening statement for the presentation here?" So hopefully it's not too make-believe. I've got some practical experience here that I can relay. No, even though we're in Ocean's 11, Brad Pitt and George Clooney aren't going to be, you know. Some of the reasons we've already talked about. Two I wanted to focus on are safety and regulatory. A lot of things can cost you money, but some of those things can cost you your business. My sister works for a company called Knapp Chemicals in New Jersey. They had a plant explosion. It bankrupted the company. So some of these safety things, if you don't do them wrong, they can put you out of business. You have a regulatory event. That can also put you out of business. The other ones can just cause a lot of problems. That's the main reason. Money.
Hang on a second.
All right. All right. I guess I got too much going here. Primary reason though is money. If you're not saving money with what you're doing today, you're not going to get approval. So yes, if you can improve quality, that's easy to justify. If you can improve throughput, that's easy to justify. But how do you justify the minimization of risk? The probability that something might go wrong, the possibility that something might go wrong. That's something where these automated manual procedures can have a significant impact in, but it's much harder to quantify financially. A couple of examples that I've been personally involved with. One was working with a product that went into, I got to switch again. Okay. Hopefully I'm loud enough you can hear me without even this stuff. But there was a product that was made that went into a pharmaceutical product. It was not an active ingredient, but it was an excipient. And as part of the manufacturing process, and manual procedure was not properly followed, and the product got contaminated from the previous product that had been through the transfer line. That one incident cost the company $2 million in liability, in lost revenue, lost reputation, lawyer fees, productivity. It was an expensive oops. And that was all because a procedure was not properly followed to flush a line out from one vessel to another. The other example was a semiconductor company where a product got packaged and shipped to a semiconductor fab. If you've ever been inside of a fabrication, these $2 billion facilities, they have big wafers with thousands of chips going through them. You screw up a batch of those wafers somewhere in the manufacturing line, it is big, big bucks. And that's what happened. There was a product that had been, the wrong product got packaged with the wrong label and got shipped to the customer. They used it in their fab and obviously didn't do what it was supposed to do because it was the wrong product. It cost, again, a $2 million price tag. I didn't make a typo there. That's really what the numbers were. The third one was one Mike wanted me to present. And I took a look at it, and I was astounded. You can see here, there's a truck would come in with a transfer hose, hook up, and transfer material through a hose into a piping header, and went into a tank. The operator comes out, unlocks the cap on the hose, and the guy was supposed to be offloading sodium hypochlorite, and he sticks it into the sulfuric acid line. And so he offloads sodium hypochlorite, which is essentially bleach, into an acid. And what happens when you do that? What chemical reaction results?
Sounds like a
Chlorine
chlorine release.
There was a massive chlorine release from a tank load. By the time it was realized what was happening, the truck driver could not get to the truck to shut off so the entire contents of the truck went into a tank. Chlorine gas was released all over the place. There were 140 people injured from that. Luckily, no fatalities. There was a release into the community. So there's a video here. I'm not going to show. It takes too long. Very well done. The Chemical Safety Board has some excellent videos talking about problems that they've had to go research. And I've seen several of them, and you'll be surprised how many of them have to do with procedural actions that have gone wrong. Oops. Now I did it. Can somebody get me back? Your back button on this thing doesn't really seem to work.
Yeah.
So I didn't know, Mike, we didn't share all of our slides at the same time, so very much the same type of things here. Why do procedures not work? And we've talked about people in training, accessibility, stability, interconnectivity. There's lots of reasons, and I think people realize that they don't always work. One of the issues that I see is with the procedures that I've been encountering is the procedures are written for the happy path. What happens when you do this? Okay, you do this, then you do this, and then you do this, and they do this. They are not designed to lead the operator through what happens if something doesn't work properly. And as I said, I worked in batch plants primarily. When I specify a batch plant, more than 50% of my work is describing what to do when something breaks. Most written procedures do not go into that detail. So replacing a written procedure from a clipboard piece of paper to a e-glass, an electronic procedure on glass, doesn't solve the problem. You have to completely rewrite how you write your procedures, what the procedure contains, and give the operator information on what to do if he encounters a problem in that procedure. It takes a lot more work, but it is much, much more effective. We're wireless now, everything's portable. I mean, your cell phone. Whoever would have thought 25 years ago you walking around with a computer that you could talk to the world in? It's just going to get more and more endemic. So portability is one of them. Barcoding, QR codes, barcodes. I was talking with Matilda back there in terms of our RUCO codes, which are QR codes. It's a 2D code, but it gives you orientation information. One of the interesting uses for it is you have a code on a hand valve. You can take a picture of it. It will tell you if that valve is in the horizontal or the vertical position. So there are RFID, all kinds of things that are going here. You see a real-wear headset on this guy. So portability is changing the world. I was looking for the slides on the workforce. Everybody has heard the aging workforce is leaving, the younger generation is coming in. My 1-year-old granddaughter can pick up my cell phone, and she knows how to push her finger across the screen to make the pictures go from one picture to the next. These kids are growing up with this stuff, and they're not going to be satisfied with a piece of paper on a clipboard. I work with a high school robotics team. I've been working. My daughter got me involved when she was a senior in high school. She left 12 years later. I'm still with the team. I work with the programming team, but we also have a CAD team. We build 150-pound robots in about 8 weeks. We compete statewide and then internationally if we get to Worlds. If you ever get a chance to get involved with the FIRST organization, I highly recommend it. This is the biggest group of attention disorder teenagers you can ever work with. But it is fun, it is rewarding, but these kids are growing up with computers in high school. That third slide over there is a light sensor, a lighting system that I built to go around a camera that we use for vision recognition. We have targets that are highlighted by green lights. We find the shape of the target. We know how far we are from the target, what angle we are from the target. We can use that in a feedback PID control loop. I have to teach them PIDs. Our workforce is going to be out there and expecting something much better than a written paper procedure. And now I'm going to start getting into some of the mechanics of, I talked about the happy path. Procedures have to be adaptable. As I said, 50% of the requirement that I write is how to write an adaptable procedure. So the procedure typically is not written in Word anymore. You can't give an office professional a procedure, have her write it up, and expect that that's done. We are working with modern tools. This is one example of a workflow engine where you automate a workflow process. You connect action blocks. You make decisions in these blocks. You can branch. You can loop. You can do calculations. There are things that, it was interesting, when Mike and I started talking about dynamic procedures, he was talking about dynamic in relationship to time and equipment and place. I was talking about dynamic in the real-time mode in terms of dynamic in, okay, I get this reading right now, which do I go? I get this reading now, where do I go? So there's two time domains that we're talking about dynamic. Procedures have to accommodate both of them. Connectivity. Like I said, paper and glass doesn't work. You have to have connectivity. All these buzzwords, ODBC, OPC, SQL, most of people now in this Internet of Things activity, that's why we're here, the digital transformation, we have to have connective procedures. We're going to be looking up lookup tables. We're going to be looking up LIMS results. We're going to be looking up quality data. We're going to be looking at DCS values. And vice versa, this procedure in the field is going to be supplying information to these systems. Right now, an operator comes back with a written procedure. He's written all this stuff on the clipboard. He comes back. He usually has to type it into an Excel spreadsheet, and that's just prone for error. Translation errors, transformation errors, puts the wrong information in the wrong block at the wrong time. So connectivity has to be a requirement for a workflow engine. I've tried to put up some examples here. Mike had some examples. I worked from the batch plant, but typically material transfer is one area where manual procedures are endemic to almost every process. It is extremely difficult to automate every single material transformation. And so lots of examples with rail car, tanker ships, tank farms, but there's also lots of other examples. Startup procedures, shutdown procedures, maintenance procedures, red tag, lockout, tagout procedures. There are many, many examples where people are using written procedures right now, but they're not integrated with the control system, they're not integrated with the databases, they're not integrated to any handshaking control systems, but it needs to be. How many people are familiar with the BPMN notation, Business Process Mapping Notation? A few, not many. This is a tool I think you should learn how to use. It is an OMG standard. It's in version 2. It is a way to take procedures and document what happens in the procedure. What you have here is called a pool. And you have swim lanes in the pool. You have functional groups that are performing actions in the pool. And you have, it is hard to read, and I will go through what this thing does. But essentially, I have a material transfer procedure here. And this is a highly simplified condensed version of a procedure that I was working on. But I have operations here. They get the order, they send it down to manufacturing. The control center gets it, they start it. They're part of the DCS process. I have a terminal operator here who is responsible for hooking up the rail car, the tanker, the truck or something out in the field. And I have a guy in the tank farm here who has to make sure at the destination that the right valves are open. So this is a way to document a procedure, and all of these dotted lines are lines of communication between the procedures. Right now, it's usually done with Hank on the handset, or somebody picks up the phone, or maybe if they are allowed to use their cell phone in the process, he gives them a call. But he's telling them what's going on, and what I'm suggesting is every time you have one of these dotted lines, it's an opportunity for failure. It's an opportunity for something to go wrong. It's an opportunity for the wrong information to be transferred. And it's also lost time. If somebody's waiting for a phone call and then finally he goes out to lunch and then finally comes back, he may have lost half an hour of time. And in some cases, that's thousands of dollars of lost asset utilization. So it's a way of taking a process and defining within each one of these blocks. There's usually lots and lots of activities in that block, but it's centric to that one person or that one function. So these can be nested, much like a process control system can be nested in terms of procedures, recipe procedures, operations and phases. These things are very similar in terms of the nesting and the communications that have to happen between them. Usually, what we see in here is the communication lines are done with OPC tags. It's your universal transfer media, and it's an easy way to get one system to talk to another. But you can also communicate through SQL databases, Excel spreadsheets, lots of different ways, but it's a handshaking between procedures running in parallel, but all trying to achieve the same purpose. So I go into this a little bit. I'm not going to spend a lot of time. The idea is by an analysis of your procedure, you can go through, identify the actions, identify the workflows to identify the workflow contents. I simplified it, and then I simplified it some more, and then I dug into it. And you can't read that, I know. But what you see here is I highlighted the lines of communications, and then the big yellow things are the blocks of data that are sent. Believe me, this is nowhere near comprehensive in terms of the amount of data that can or should go between procedural actions. They're just representative examples. Mike talked about failure mode effects analysis. This is a way where you can take your procedure and look at every line of communication, look at every block, and figure out what can go wrong in this section of the procedure. And a highly informative process that should be done on almost every procedure. And like I said, this one was just documenting the happy path. I didn't do all the looping and branching and things on things if it was the wrong material at the wrong place at the wrong time with the wrong quality. That all has to be part of the procedure. Short-term, dynamic connectivity of real-time information. Critical to success of automating manual procedures. Is there anybody here who's, besides Lindy, who's presenting next, who's doing automation of manual procedures? A couple, okay. You all have DCS systems, right? Do you have batch execution engines? So some are saying yes, that's a manual procedure, that's a procedure engine. We're starting to get, though, into procedure engines for manual workflow operations. And that's what we're trying to define here. Again, information, data flows, actions, a very good way of defining procedural actions. In this particular example, the control room gets notified, the field gets notified. They are given a lineup, they're given a material, they're given a quantity, they're given what valves and pumps or motors that they have to inspect or expand. So there's information that gets through, and then when that is done in the field, I don't have to give the guy a phone call. He's already got that information. The DCS has that information. He can act on that information, or he cannot act on that information if it's the wrong information, which is just, as I said, just as critical, like that pipeline hookup. The guy had it hooked up, but he put it into the wrong place. Continuous updated communications with current processing. The guy in the field knows it's pumping, he knows it's transferring, hasn't been notified, so he's out there looking for leaks, looking for problems, looking at the pump, looking at the filters. And it goes on and on. I am just going to spend about 1 second on each one of these lines, and you can dynamically see that if this were animated and observable, you could see where the process was, what it was doing. You could see the contents of any one of those blocks. You can follow the procedure through. Every procedure has a start and a finish. You would say, well, never, I have some things that never end. Well, they're typically an instance of a procedure. You can document instances of a continuous procedure. So, and then we're finally all done. So this is a tool, a methodology of looking at procedures and helping a transformation of an existing written handheld procedure to something else. So in summary, procedures are everywhere. Plant and business I'm working in right now, they have a DCS system. They make material which is sold for thousands of dollars a liter, but it is highly manual operations. And at the beginning of the shift, at the beginning of the batch, at the beginning of every procedure, they go out and they print out something and they put it on a clipboard and they go out. And during the day or the week, they're running this procedure, and I'm just shaking my head. I'm trying to get them to change. That's it.